12 units.
Okay.
The B.Sc first sem. So you know myself, Kemparajegowda, Dr. Kemparajegowda. So, in the first semester, in the B.Sc first semester, I'm going to take organic unit 5. Organic unit 5. Organic chemistry unit 5 ಅಂತಿದೆ. ಅದರಲ್ಲಿ ನೀವು ಆ ಚಾಪ್ಟರ್ ನ ಜೆರಾಕ್ಸ್ ಮಾಡಿಸ್ಕೊಳ್ಳಿ ಅಥವಾ ನಿಮ್ಮ ಸಾಫ್ಟ್ ಕಾಪಿ ಇದ್ರೆ ಸಾಫ್ಟ್ ಕಾಪಿ ಓಪನ್ ಮಾಡ್ಕೊಳ್ಳಿ. ಸೊ ಅದರಲ್ಲಿ ನಾವು ಡೆಫಿನಿಷನ್, ಇಂಪಾರ್ಟೆನ್ಸ್ ಆಫ್ ಆರ್ಗ್ಯಾನಿಕ್ ಕಾಂಪೌಂಡ್ಸ್, ಕ್ಲಾಸಿಫಿಕೇಶನ್ ಆಫ್ ಆರ್ಗ್ಯಾನಿಕ್ ಕಾಂಪೌಂಡ್ಸ್, ಸೊ ಟೆಟ್ರಾ valency of carbon, and what is SP hybridization, what is SP2 hybridization, ಇದು ನಿಮ್ಮ ಸಿಲೆಬಸ್ ಅಲ್ಲಿ ಇರುತ್ತೆ. అంటే hybridization ಅಂದ್ರೆ ಬಾಂಡ್ ಲೆಂತ್, ಬಾಂಡ್ ಆಂಗಲ್, ಬಾಂಡ್ ಎನರ್ಜಿ, so localized and delocalized chemical bonds. So these are the syllabus of organic chemistry, right? So next ಅದರಲ್ಲಿ isomerism ಇದೆ, ಅದರಲ್ಲಿ ಟೈಪ್ಸ್ ಆಫ್ isomerism ಇದೆ, ಆಯ್ತಾ? ಇದಿಷ್ಟು ನೀವೇನಷ್ಟು ಫಸ್ಟ್ ಯೂನಿಟ್ 5 ಓದ್ತಾರೆ. ಯೂನಿಟ್ 5 ಓದುವಂಥದ್ದು ಇದಿಷ್ಟು ಆರ್ಗ್ಯಾನಿಕ್ ಅಲ್ಲಿ ಇದು ಯೂನಿಟ್ 5. ಸೊ ಇದು ಯೂನಿಟ್ 5 ನೀವು ತಗೊಂಡ್ರೆ okay. So in the unit 5, so introduction. So what is organic chemistry ಅಂದ್ರೆ ಏನು? The compounds like so usually application. So what is organic chemistry? So organic chemistry is the study of carbon, hydrogen. The study of carbon, hydrogen in organic compounds. So in organic compounds, adana enante the study of carbon and hydrogen is called study of carbon and hydrogen is called organic chemistry. Or ಇನ್ನೊಂದು definition ಅಂದ್ರೆ the study of preparation, reaction and composition. Composition of carbon and hydrogen related compound. Carbon and hydrogen related compound reactions, composition, preparation study madadre, that is also called organic chemistry. The preparation, reaction and composition of carbon and hydrogen related compound study of related compound is called what? Organic chemistry. So one more you can take structure also. So this is related. Here structure can say structure. So preparation, reaction, structure and composition of carbon and hydrogen related compound is called organic chemistry. The mainly The compounds like sugars, fats, proteins. Daily uses are not whether we are eating proteins. So proteins, vitamins, etc. Yeah, regularly we used in our daily life. So we are regularly used in our daily life. These sugars, fats, proteins contains organic compounds. We know these molecules are very important for ourselves, for our living organisms. It is very important for all living organism to lead their life in condition. So all living organism needs these compounds to lead their life in live condition. So this, we know that many. So the next I'll take. So in the long bag, they believed that organic compounds were not synthesized in the laboratory. They are not synthesized in the laboratory. They believed laboratory synthesize madakagala anta. Since so it requires the presence of mysterious force. So the presence of mysterious force is that vital force. It needs vital force. It needs vital force. So vital force which exists only in the living organism. Only in the living organism. So in the previously they thought the vital force which exists only in the living organism, but in 1828, Friedrich Kohler, he first synthesized the urea. One of the scientists is called Friedrich Kohler, synthesized urea in 1828. So after 1828, first Friedrich Kohler synthesized urea molecule in the laboratory by beating ammonia cyanide. This is the first compound in the organic chemistry. The urea is the first compound synthesized in the laboratory. This is the first molecule to prepare in the laboratory. After this synthesis, people believe that no vital force acting for synthesis of organic compound. There is no vital force. Vital force acting for the synthesis of organic compounds, and they can also be synthesized in laboratory. So they can also be synthesized in the. This changes the definition of organic chemistry. So definition in the people mind. According to the modern definition, organic compounds are defined as hydrocarbons and their derivatives. And the study of hydrocarbons and their derivatives is called urea structure. Hydrocarbons are carbon and hydrogen. So this is the urea structure. The study of hydrocarbons and their related derivatives is called organic chemistry. So
Sir, ammonium cyanate.
Ammonia cyanate.
Sir.
Ammonium cyanate. Okay. So the basic things which are essential to understand the study of organic compounds. So very basic things is very important to understand the organic compounds, like types of bonds. What are the types of bonds in them? Their structure. What are the factors which have direct impact on the physical and chemical properties of organic compounds? Very basic things we need. Essential. Like a bond What are the types of bond present? For example, this is ethane. Okay. Or you can take methane also. So this is methane. What are the types of bonds here present? These are the basic things we need. What types of bonds present in there, in them, and structure. What is the structure? What is the structure of organic compound, and what is the physical and chemical properties? What is the physical properties? So there is what temperature can override, or what is the chemical properties? So these are the basic things we need to understand. So this is the organic chemistry branch of chemistry, in which the study of structure, properties, composition, reactions, and preparation of carbon and hydrogen. Preparation of carbon and hydrogen containing compounds are included. Are included. Okay, so this is this is single bond. This organic compound is ethane. Ethane contains single bond. Next, this one, double bond. We call this one double bond. Next, what is this compound? This contains triple bond. Ethane, acetylene. This is also called acetylene. This contains what? Triple bond. So these are all open chain. Open chain. You can check closed chain. Closed chain. Okay. So this means the structure is like this: CS2, PS2, PS2, PS2. So this one. Closed chain. Closed chain. And this is open chain. This is single bond, double bond, triple bond. So white bonds carbon with white carbon bonded with hydrogen, like hydrogen, next nitrogen, and chlorine, oxygen. So the similarity in electronegativity. So electronegativity of carbon is 2.5. This hydrogen is also almost is equal to 2.1. This is 3.5. So nitrogen, so 3.5, sorry, 3.0. So nitrogen electronegativity is 3. And oxygen 3.5. This is around 2.7, I think. 2.7. So phosphorus. So these are all. So phosphorus 2.1. So due to very near electronegativity, this is electronegativity of hydrogen, nitrogen.
Oxygen 3.5.
Huh? 3.5.
Oxygen 3.5. Sir.
3.5. Due to its similar size. So carbon, hydrogen, nitrogen, chlorine, phosphorus, same periodic table almost near 1 or 2 difference. The due to its small size carbon atom has strong tendency to form multiple bonds with carbon itself. Form carbon itself, multiple bond, like double bond, triple bond. With nitrogen also, and oxygen and sulfur. It takes sulfur also. So these are heteroatoms in the organic chemistry. So these are heteroatoms. This is closed type. It forms covalent bond.
Sir, what is electronegativity, sir?
Carbon bond, covalent bond with all these elements. It forms covalent bonds with all these elements due to almost near electronegativity and small size of carbon. So classification of organic compounds. Classification. Classification. So classified into acyclic or open chain. First one, acyclic or open chain. Next, second one, acyclic or open chain. Cyclic or closed chain. Cyclic or closed.
Closed chain complex.
Acyclic ಅಂದ್ರೆ ಗೊತ್ತಿದೆ ನಮಗೆ. ಓಪನ್ ಚೈನ್ ಇರೋದು. So this is open chain or acyclic. So,
Excuse me, sir. Some
Yes.
are asking votes now.
what? Yes.
Somebody asked what is electronegativity?
So electronegativity means, so it is a capacity to hold electron itself. So what is the capacity of carbon to hold itself? See, this is a carbon atom, nucleus, and this is an electron around the nucleus, proton and neutron inside. So electron ಎಷ್ಟು within ಎಷ್ಟು electron ಇದೆ, capacity to hold an electron towards itself. That is called electronegativity. ಅರ್ಥ ಆಗ್ತೀಯಾ? So oxygen, for example, chlorine has highest electronegativity. So it won't donate easily electron. It itself, ಏನ್ ಮಾಡುತ್ತೆ itself, it's pull itself, electron pull itself towards nucleus, chlorine. That's why the electronegativity of fluorine is 4. So electronegativity means capacity to hold electron. Okay na?
Yeah, sir.
So this is open chain. So cyclic ಅಂದ್ರೆ ಗೊತ್ತಿದೆ. So this is cyclic. So cyclic. So cyclic. So acyclic further divided into saturated, unsaturated. Acyclic now further divided into saturated, unsaturated. Unsaturated. Saturated means single bond. Single bond is called saturated. Double bond is called unsaturated. So saturated. So this is saturated, but double bond is unsaturated. These are all unsaturated. Requires hydrogen. ಆಯ್ತಾ? Saturated ಅಂದ್ರೆ at least one carbon. Unsaturated. Unsaturated means at least one carbon double bond. ಆಯ್ತಾ? One carbon multiple bond ಇರೋದು. Carbon multiple bond is called unsaturated. At least one. Here no multiple bond in the saturated. Saturated means single bond only. Unsaturated, at least it contains one multiple bond, like carbon double bond or carbon triple bond. So next, homocyclic, heterocyclic, cyclic type, homocyclic and heterocyclic. So homocyclic means it contains only CH bonds. Only CH bonds. So this is CH2. Cyclopropane. So this is homocyclic. So heterocyclic means at least it contains one hetero atom. So what are heteroatoms? Heteroatom means other than carbon and hydrogen. So for example, oxygen, nitrogen, sulfur, phosphorus. So these are all heteroatoms. At least a ring contains one heteroatom, then it is called heterocyclic. Acyclic compound. At least one of the hydrogen in the ring is replaced by heteroatom. It's called heterocyclic chemistry or heterocyclic compound. One of the carbon replaced by hetero. This is called heterocyclic. This is the example. Okay, now next functional group. So functional group. Next. So what is functional group? The functional group are characteristics arrangement. Characteristic arrangement. The functional group next. Functional group. Characteristic arrangement of atoms. Define many of the physical and chemical properties of organic. Define many of physical. It's defined the chemical. The functional group defines many of physical and chemical properties. Chemical
We can't hear.
properties and chemical properties of organic.
Sir, in phone ಬರ್ತಿದೆ. Sir, repeat once, sir. We disturb us.
Organic compound. Done. So, it's define many. It define many of physical and chemical properties of organic compound. The simple form of functional group found in the organic compounds contains only carbon and hydrogen atoms are the hydrocarbons. Only carbon hydrogen is the functional group. This is alkene. Contains only carbon and hydrogen, but is functional group double bond alkene and the This is called hydrocarbons, which include the alkanes, alkynes. This alkynes.
ನೀವೇ ಮಾಡಿದ್ದು
ಯಾರದು?
ಕಾಲ್ ಮಾಡ್ತಾನೆ ಇದಾರೆ.
ಆಶಾ ಮೇಡಮ್ ಸ್ವಲ್ಪ ನಿಮ್ದು ಮ್ಯೂಟ್ ಮಾಡಿ.
ಓಕೆನಾ? Alkynes. CH. So this is alkyne. Okay. So the alkyne and alkenes and aromatic. These are all the functional group, but these are all hydrocarbons. Hydrocarbons containing functional group. Many functional groups present in organic molecules contains oxygen. Many functional groups in the organic compounds contains oxygen, nitrogen, sulfur, along with hydrogen and carbon. Along with carbon and hydrogen. Many functional group contains oxygen, sulfur, nitrogen, along with carbon and nitrogen. For example, carbon and hydrogen and oxygen functional group. Next, few examples. For example, alcohol. See, methanol. So if you substitute R is alkyl. This is methanol. It's an alcohol. Functional group. Alcoholic functional group. What is this? Ether. This ether. Okay. Ether. Next. After ether, you can take many examples. Aldehyde. So this is aldehyde functional group. Next, you take carboxylic acid. Next, you take ester. This is carboxylic acid functional group. Carboxylic acid. This is an ester functional group. This alcohol. This alcohol, ether, this aldehyde. So these are oxygen containing functional groups with hydrogen and carbon, with carbon and hydrogen. Some functional group present in the organic molecules contain nitrogen. So it contains nitrogen. So this is nitride. And this is if nitrogen first bond. Isocyanate. This isocyanate. This nitride, amine, It's amine. The functional group name amine isocyanate, nitrile amide. CONH2 is CONH2 is for amide functional group. Aita? So these are imine, or double bond N-cis2 is so these imines and also diazo compounds. So these are all diazo compounds. Diazo compounds. Next, some for present in organic compounds contain both amine and oxygen atoms along. So both nitrogen and oxygen, hydroxylamine, oxygen, hydroxylamine. So this nitrogen and oxygen containing amide. Both nitrogen and oxygen containing functional groups. So amide, hydroxylamine, and many such functional groups are the NO2, nitro group. These are all functional groups. These are all functional groups. So next, isomerism anta barata. Next, isomerism. Isomerism. So what is isomerism? So for a chemical formula C3H8O. So you can write three structures for this. You can write three structures. You can write this one CS3O, CS3, and this is O, CS2. CS2, CS2. So this you can write one formula for this, and next CS3 and CS3. One alcohol, one ether. So this is secondary alcohol. This ether, same chemical formula. Can write different structures, and even primary alcohol we can write. This 3, this CS2. This primary alcohol. This primary alcohol, ether, the same chemical formula, you can represent different structures. Structure 1 is ether, structure 2 is alcohol, secondary alcohol, structure 3 is primary alcohol. So all three structures are same with respect to their chemical formula. The chemical formula same, but they are different one another by the structural formula. They are different one another by the structural formula. Also, their physical and chemical properties is different. Ether physical and chemical properties is different. Not even secondary alcohol, your physical and chemical properties is different. And alcohol, primary alcohol, this which melts at 30 degree, evaporates at 30 degree, but this melts at 50 around 50 degree Celsius. See, the physical property is different. The boiling point of ether is 30, but boiling point of secondary alcohol is 50. That's why the physical and chemical properties are different. Thus, organic compounds may have same chemical formula, but they have different structural formula. So, are called isomer. Means chemical compounds that have identical chemical formula, but differ in structural and chemical but different structural, chemical, and physical properties are called isomers. But different in structure, chemical, and physical properties are called isomer. The phenomenon is called isomerism. A phenomenon ಅಂತ ಕರಿತೀವಿ isomerism ಅಂತ ಕರೀತಾರೆ. Two types of isomer. Two types of isomers. Structural isomer, structural isomerism. Next, symmetrical isomerism. Next one, or stereo isomerism. Structural isomerism, stereo isomerism. The compounds have the same molecular formula but different structural formula are called structural isomers, and the phenomenon is called structural isomerism. There are only two types: structural isomerism and stereo isomerism. Structural isomerism many types are structural isomerism. So ಯಾವುದು ಇದೆ? chain isomerism. So first type ತಗೊಳ್ತೀನಿ. ಅದರಲ್ಲಿ types first types ಅಲ್ಲಿ structural isomerism, chain isomerism. Chain isomerism ಅಂದ್ರೆ for example ನೋಡಿ. So this is CH3, CS2, butane. You can write this one as like this: CS3, H. Okay. Chain. This what? Linear chain. This is branched chain. Chain has a difference. Same chemical formula. Yes, you can count hydrogen and carbon same, but chain is different. Next, position isomerism. Position isomerism. In position isomerism, take this one. This is OH entail. So this is OH, secondary alcohol. If you change the position of OH, CS2, BH2, and CS3. The position is different. This is 2 position, this 1. Position is 2, this 1. Functional OH. Next, functional isomerism. Functional isomerism. Take this is CS3O, CS3. Dimethyl ether. This is functional. Functional group is different. Ether. The same chemical formula. I write like this: ethanol. So this ether, this alcohol. This ethanol. OL and alcohol. See, same chemical formula. This ether, but this ethanol. That's why it is functional isomerism. The next, for metamerism. Metamerism ಅಂದ್ರೆ same functional group same ಇರುತ್ತೆ. Functional group same, CS2, CS3. But if you change the position, oxygen position here, this CS2 will take this CS3, CS2, and this is CS2, and this is CS3. See? This O, this CS2, this CS2. So metamerism, the position is ether is 1 methyl ether, but here ethyl. See, this is ethyl, diethyl ether. Both side ether, so that's why diethyl ether. But here metamerism andre same functional group same, but position of oxygen position is different. That is metamerism. In tautomerism, next fifth one. Tautomerism. Okay. So this is keto-enol tautomerism. Keto-enol. Ketone is the enol. So this is the ketone. This is actually acetone. Acetone ಇಂದ ಈ ಒಂದು ಹೈಡ್ರೋಜನ್ ಆಕ್ಸಿಜನ್ ಕಡೆ ಶಿಫ್ಟ್ ಆಗುತ್ತೆ. ಅದನ್ನ keto-enol tautomerism ಅಂತ ಕರೀತೀವಿ. ಈ ಹೈಡ್ರೋಜನ್ ಇದೆಯಲ್ಲ, ಈ ಹೈಡ್ರೋಜನ್ ಈ ಆಕ್ಸಿಜನ್ ಒಂದು ಹೈಡ್ರೋಜನ್ ತಗೊಳ್ಳೋದು. ಇದು ಇಲ್ಲಿಗೆ ಡಬಲ್ ಬಾಂಡ್ ಫಾರ್ಮ್ ಆಗುತ್ತೆ, ಸಿಂಗಲ್ ಬಾಂಡ್ ಆಗಿ OH ಆಗುತ್ತೆ. This is enol form. This is called tautomerism. So in the depth, in the full details in the textbook SLM ಅಲ್ಲಿ ಇದೆ, read ಮಾಡಿ. ಏನೋ ಡೌಟ್ ಬಂದ್ರೆ ನೆಕ್ಸ್ಟ್ ಕ್ಲಾಸ್ ಅಲ್ಲಿ ನಾನು ಏನ್ ಮಾಡ್ತೀನಿ ಅದನ್ನು ಸಾಲ್ವ್ ಮಾಡ್ಕೊಡ್ತೀನಿ. ಅದು ಆಯ್ತಾ, ಮೆಟಾಮೆರಿಸಮ್ ಆಯ್ತು, ಟೌಟೋಮೆರಿಸಮ್ ಆಯ್ತು. ನೆಕ್ಸ್ಟ್ ಸ್ಟೀರಿಯೋ ಐಸೋಮರ್ಸ್, ಸ್ಟ್ರಕ್ಚರಲ್ ಐಸೋಮರ್ಸ್ is structural isomers. Next, second type, stereo. Stereo isomers are two types. First type, geometrical. Next type, optical. These are two types. Geometrical and so for example, I will take malic acid. This is COOH. Geometrical get there must be a double bond. Double bond related. So double bond condition. One condition is geometrical get double bond related. This is malic. Malic acid. Another one trans. Isomeristic acid. This is isomeric acid. So this is geometrical cis trans. This is cis trans. Opposite side. Same side is cis. Opposite side is trans. This is called cis and cis trans. Condition for geometrical isomer: there carbon. There should be a double bond in the molecule. The two atoms or groups attached to each double bonds carbon atoms should be different. If one of the two double bond carbon atoms carries two identical groups, double bond carbon atoms carries two identical groups at the identical group, then the molecule does not exhibit a geometrical isomer. ಅಂದ್ರೆ ಡಬಲ್ ಬಾಂಡ್ ಇರಬೇಕು. ಈ ಡಬಲ್ ಬಾಂಡ್ ಇದ್ದಾಗ ಫ್ರೀ ರೊಟೇಷನ್ ಇರಲ್ಲ ಇಲ್ಲಿ, ಆಯ್ತಾ. ದೇರ್ ಇಸ್ ನೋ ಫ್ರೀ ರೊಟೇಷನ್. ಸೊ ದಿಸ್ ಇಸ್ ಕಾಲ್ಡ್ ಸಿಸ್ ಟ್ರಾನ್ಸ್. ಸೊ ನೆಕ್ಸ್ಟ್, ವಾಟ್ ಇಸ್ ಆಪ್ಟಿಕಲ್? ಆಪ್ಟಿಕಲ್ ಅಂದ್ರೆ ಐಸೋಮರ್ಸ್, ಐಸೋಮರ್ಸ್, ಬಟ್ ಹಿಯರ್ ದ ಕಾರ್ಬನ್ ಅಟ್ಯಾಚ್ ಟು ಆಲ್ ಡಿಫರೆಂಟ್ functional, all different. Carbon now, they are different functional group or atom. ಯಾವ್ದಾದ್ರು ಆಯ್ತಾ ಅಟ್ಯಾಚ್ ಆಗಿದ್ರೆ ಅದನ್ನ ಏನಂತ ಕರಿತೀವಿ? This is mirror image, but we can't ಇದನ್ನ ತಗೊಂಡಾಗ ಇದನ್ನ ಇಡಕ್ಕಾಗಲ್ಲ. We can't superimposable. Mirror image is not superimposable. So optical isomers ಆಗಿರ್ಬೇಕಂದ್ರೆ there is one must condition: the carbon should be chiral. Chiral ಅಂತ ಹೇಳ್ತೀವಿ. Chiral ಅನ್ನೋದೇನಕ್ಕೆ ಕಾರ್ಬನ್ಗೆ? ಸೊ ಕಾರ್ಬನ್ 4 ಡಿಫರೆಂಟ್ ಆಟಮ್ಸ್ ಆರ್ ಗ್ರೂಪ್ಸ್ ಅಟ್ಯಾಚ್ ಆಗಿದೆ. ಆ ಕಾರ್ಬನ್ ನ chiral ಕಾರ್ಬನ್ ಅಂತ ಕರಿತೀವಿ. Only chiral carbon process are shows optical isomer. ಆಯ್ತಾ, optical isomer. This shows optical isomer. This is the condition. So optical isomers ಆಗಬೇಕಂದ್ರೆ that carbon should be chiral, then it possess so optical isomer.
Sir, meaning of chiral. Chiral meaning ಹೇಳಿ sir.
Chiral meaning means the carbon is chiral here. ಆಯ್ತಾ,
ಕಾರ್ಬನ್ chiral ಅಂತ
because see this is not chiral. See H, this H, CS3, for example, and this is the OH. These carbons contains two similar atoms here. But in chiral atoms, chiral carbon, it should not contain all same. So it should contain all four atoms are different. And the carbon attached groups different ಆಗಿರ್ಬೇಕು. ಆಯ್ತಾ?
Okay, sir.
ಅರ್ಥಾಗ್ತಿದ್ಯಾ? See, here you observe here, this carbon attached hydrogen, OH, alcohol, and alkyl, CS3, and carboxylic acid. The four different atoms or groups are attached to carbon. Here, functional groups will attach acid, hydrogen, alcohol, CS3. All are four different. That's why it is chiral carbon. Here, you observe this is alkyl, this is acid, but these are two hydrogen, symmetrical. There are symmetry is there. Symmetry andre so ನೀವು ಏನು ಮಾಡ್ತೀರಾ ಡಿವೈಡ್ ಮಾಡಿದ್ರೆ ಡಿವೈಡ್ ಇಂಟು ಈಕ್ವಲ್ ಆಲ್ಸೋ ಅಂದ್ರೆ ಏನೋ ಸಿಮಿಟ್ರಿ ಇರುತ್ತೆ ಅಂದ್ರೆ ಯಾವುದೇ ಸೇಮ್ ಆಟಮ್ಸ್ ಹೈಡ್ರೋಜನ್ ಸೇಮ್ ಆಟಮ್ ಇದೆ chiral. So carbon for example ನೋಡಿ chlorine, hydrogen, and then you take bromine. So this compound is chiral because carbon is attached to four different atoms. That's why it is chiral. Okay, na? So that type of compound. Next, the types of orbitals. The types of orbitals, according to the atomic theory and the quantum mechanics, in atomic orbital, it's a mathematical function. So it's a mathematical function describing the location and wavelength behavior of electron. Location and wavelength behavior of electron. Wavelength behavior of an electron in an atom. This function can be used to calculate the probability of finding an electron. So, andre location ಮತ್ತು wavelength behavior of electron. ಒಂದು atom ಅಂದ್ರೆ ನ್ಯೂಕ್ಲಿಯಸ್ ಇರುತ್ತೆ, ಅದರ ಸುತ್ತ ಏನಿರುತ್ತೆ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇರುತ್ತೆ. The probability of finding electron around the nucleus, how many types? ಒಂದು ಈ shape ಅಲ್ಲಿ electron probability finding S ಇದನ್ನ S ಆರ್ಬಿಟಲ್ ಅಂತ ಕರೀತೀವಿ. ಎಲೆಕ್ಟ್ರಾನ್ ಇಲ್ಲಿ ನಾವು we can find ಈ ಟೈಪ್ ಅಲ್ಲಿ ಸುತ್ತಾ ಇರುತ್ತೆ ಸರ್ಕಲ್ ಟೈಪ್, ಅದನ್ನ S ಆರ್ಬಿಟಲ್ ಅಂತ ಕರೀತೀವಿ. ಆಯ್ತಾ? ಇನ್ನೊಂದು probability. ಸೊ ಇನ್ನೊಂದು probability ಅಂದ್ರೆ so this is S orbital. ಆಯ್ತಾ? ಇನ್ನೊಂದು ಫೈಂಡಿಂಗ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್ this Z, this Y, this X. Axis. This Z, this Y, this X. This Z, this Y, this X. So this is if the electron is revolve around this shape ಅಲ್ಲಿ ಏನಾಗ್ತಾ ಇರುತ್ತೆ revolve ಆಗ್ತಾ ಇರುತ್ತೆ. ಇದನ್ನ ಏನಂತ ಕರಿತೀವಿ? ಇದು Y axis ಅಲ್ವಾ? This is 2py. If electron is finding in this region, this is the shape. Electron ಈ shape ಅಲ್ಲಿ ಏನಾಗ್ತಾ ಇರುತ್ತೆ rotate ಆಗ್ತಾ ಇರುತ್ತೆ ನ್ಯೂಕ್ಲಿಯಸ್ ಸುತ್ತ, ಅದನ್ನ 2px. Next, probability of finding an electron in this region is maximum. That's why it is 2p z axis electrons. So these are the s orbital. Is equals to idre idina p Px, Pz. So shape and orientation of p orbital. This is the shape and orientation. This is the shape of s orbital and p orbital. Of what? P orbital. Done. So next, is type of chemical bonds present in organic molecules. This is the shape of s and p orbital. Types of bonds. Types of bonds. What are the types of bonds? So head to head. So head to head, first side, head to side by side. Two types of it. One head to head, another side by side. Side by side, or this head to head overlapping, and this is side by side or lapping. So head to head already. So this orbital, I will take x. So this is head. One head. This is p orbital head. So the electron from s orbital and one electron from p orbital. So this is called sigma bond. Head to head avre sigma bond anta kari. So you can take this is axis y axis or x. This is z. This is y. If you take example s orbital andre nimage gottira hydrogen irodu 1s1. You take this is s orbital andre 1s 1 this s orbital is hydrogen ಅಂತ ತಗೊಂಡ್ರೆ example. This 1s. This 2p orbital. ನಮಗೆ ಗೊತ್ತಿದೆ 1s next 2s 2p 3s 3p electron configuration ಬರೆಯೋದು. But ನಮಗೆ ಇರೋದು p orbital 2 so that's what is 2p. This is yet to yet called yet to overlapping. It's called sigma. ಬರೀ s ಮತ್ತು ಇದು s ಇದು p. s and p orbital ಮೇಲೆ overlap ಆಗಲ್ಲ. Even s sl ಕೂಡ ಆಗುತ್ತೆ and pp ಕೂಡ ಆಗುತ್ತೆ. So s and s. S overlap. This is also head to head. And another one P to P. This P to P. ಇದು ಕೂಡ head to head. But this is TP, SS, TP, and SP. There are sigma bonds ಅಲ್ಲಿ ಯಾವ್ದು ಇರುತ್ತೆ SS head to head overlapping and SP overlapping and TP sideway like head to head overlapping. Head to head overlapping. Next side by side overlapping. Next side by side. Side by side overlapping. Side by side overlapping andre. So for example, this is p orbital and this is p orbital. Where do overlap are this? So this forms pi bond at the sigma bond at the so you call this one pi. This is side by this 90 degree. See? Side by side. Side by side overlapping is called pi bond. It's called pi bond. So you need two loops here. So the plane ತಗೊಂಡ್ರೆ upper lobe, lower lobe. So upper lobe divide ಆಗಿದೆ electrons. So upper lobe by ಸೊ ಒಂದು ಪ್ಲೇನ್ ಕಟ್ ಮಾಡಿದ್ರೆ ಅಪ್ಪರ್ ಮತ್ತು ಲೋಯರ್ ಸೈಡ್ ಏನಾಗುತ್ತೆ ಎಲೆಕ್ಟ್ರಾನ್ ಡಿಸ್ಟ್ರಿಬ್ಯೂಷನ್ ಅಪ್ಪರ್ ಅಂಡ್ ಟು ಲೋಯರ್ ಲೂಪ್ ಅಂತ ಕರಿತೀವಿ ಇದನ್ನ, ಆಯ್ತಾ? ಸೊ
Sir, can S orbitals form side by side overlap?
ವಾಟ್?
Can S orbitals form side by side overlap?
ಸೊ ಎಸ್ ಆರ್ಬಿಟಲ್ಸ್ ನೋ ಸೈಡ್. ಸೊ ಸೈಡ್ ಆರ್ಬಿಟಲ್ ನೋಡಿ ಇದಕ್ಕೂ ಆಗೋದು ಇದಕ್ಕೂ ಆಗ್ಬೇಕು. ನೋ, only form side by side. There is no interaction between two lobes. S is won't reaction with these two. It only side by side. Even SS also is only SP and this S and S is not side, head. Okay.
Okay, sir.
What is the difference between a pi bond and sigma bond? So sigma bond is stronger. So this pi bond is side by side overlapping. This weaker. This sigma bond is strong. This is weak. Pi bond is weak. This sigma bond you can rotate easily. Notice the single bond adella idu. You can rotate easily. You can't rotate here. Restricted rotation here. Pi bond. Restricted. Very important. Exam ಕೇಳದೆ ಇದು. This strong bond, sigma bond. ಅದು weak bond, side way overlap ಆದ್ರೆ. This is result of head to head overlapping. ಇದು lateral or side by side overlapping. This is side by side overlapping. This is a very important point here. This is head to head interaction sigma. This is side by side interaction. This see in this S sigma orbital, electrons are symmetrically distributed, but here electrons are not symmetrical. One is upper lobe, another one lower lobe. In the electrons appear as two lobes, one above, one below. Is not symmetrically distributed here, electrons in pi bonds, but here symmetrically distributed. All parts as well ಏನಾಗಿರುತ್ತೆ symmetrical ಆಗಿ electrons flow ಆಗ್ತಾ ಇರುತ್ತೆ, ಆಯ್ತಾ? So next, tetravalency of carbon in organic compound. Tetravalency of carbon. See, we know that carbon atomic number 6 is mass 12. Right? So write the electron configuration 1s2, 2s2, 2p2. 1s2, 2p2. So this name ಬರ್ಕೊಳ್ತೀನಿ, ಬಾಕ್ಸ್ ಬರ್ಕೊಳ್ಳೋದಾದ್ರೆ. So we know 3 orbitals. P orbitals ಎಷ್ಟಿರುತ್ತೆ? 3. Correct? 3 p's. 2px, 2py, and 2pz. We will solve this one. So this is the electronic distribution. Right? So this electronic distribution. This is carbon ground state. In the ground state, in the excited state, what happens? This 1s2, is 2s2 with 1s2. One of the electrons is excited to this electron excited to this empty here. This is called excited state. So actually energy level diagram bataga niyo. This is lower energy 1s2. This 1s2. This is 2s2. Higher energy. And this is higher energy. 2p2 here. ಈ ತರ ಇರುತ್ತೆ. ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ, ಇದು ಗ್ರೌಂಡ್ ಸ್ಟೇಟ್. In the excited side, this electron excited to 2p, 2 state. ಈ ಸ್ಟೇಟ್ ಎಕ್ಸೈಟ್ ಆಗುತ್ತೆ. ಸೊ ಅಲ್ಲಿ ಎಕ್ಸೈಟ್ ಆದ್ರೆ you get, so this is actually 1s2, this is 2s2, This is 1, 2, 3. 2s2 is 1s2. This is now 23. ಇದು 2p1 ಆಗುತ್ತೆ. ಯಾಕೆಂದ್ರೆ ಒಂದು ಎಕ್ಸಾಕ್ಟ್ ಆಗಿದೆ. ಓಕೆನಾ? This is excited state of carbon. Excited state of carbon. This is what Px, Py is Pz. Is Pz. Excited state. ಆಯ್ತಾ? ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ, ಈ ಪ್ರೋಸೆಸ್ ನ ಏನಂತ ಕರಿತೀವಿ? ಹೈಬ್ರಿಡೈಸೇಷನ್ ಅಂತ ಕರಿತೀವಿ. The process of redistribution of See, distribution and the redistribution of the energy by mixing different orbitals. Mixing different. Here we are mixed here S and P different. We mixed. So mixing different orbitals of individual atoms under carbon atoms are individual atoms in the same energy level to give new orbital of equivalent energy is termed as hybridization. The new orbital in this process are named as the hybrid orbital. So hybrid orbital andre illi carbon ಹೆಂಗ್ ಬರ್ಕೋಬಹುದು ಅಂದ್ರೆ ನಾವು ಏನಾಗುತ್ತೆ, so ಇದು 2s2 and then this is carbon. This is mix. ಇಲ್ಲಿ ಏನಾಗಿದೆ, S ಮತ್ತೆ P ಆರ್ಬಿಟಲ್ ಮಿಕ್ಸ್ ಆಗಿದೆ. 1 2 3 4. 1 2 3 4. So this is called orbital. Same 1 2 3 4. ಇಲ್ಲಿ ಯಾವ್ದು ಮಿಕ್ಸ್ ಆಗಿದೆ? ಒಂದು S, ರಿಮೈನಿಂಗ್ ಏನು ಎಷ್ಟು P ಇದೆ? 3. ಸೊ ಅದಕ್ಕೆ ಇದನ್ನ SP3 1s P3 ಅಂತದ್ದು ಎಷ್ಟಿದೆ? 4 ಇದೆ. 1 2 3 4. See, SP1s and 3p, SP3. These are all SP3 hybrid orbitals. See, here I have definition of mixing of redistribution of the energy, the mixing of different orbitals, mixing of S and P, different orbitals of individual atoms and the same energy levels to give new orbitals. New orbitals of the equivalent energy is termed as hybridization. So what are the types of hybridization found? Types of hybridization. So SP hybridization, SP2 hybridization, SP3 hybridization. You notice SP3 is the hybridization. Notice. So what is the SP hybridization? So carbon triple bond as SP hybridization. This 50% S character and 50% P character. What is SP2 hybridization? So this is double bond. This is 35% S character and 65% P character. In the SP3 hybridized, this is the SP3 hybridized single bond. Ella carbon adike 4 valence irodikku carbon 1 2 3 4 andre this is actually paragon. Illi side overlap agutte idu ee carbon ge inna remaining ee orbitals iruttala carbon hydrogen 3 hydrogen sigma bond 2 sigma bond hydrogen. This is hydrogen and this is also hydrogen. Here hydrogen. See 1 2 3 1 2 3. Here sigma bond 1 2 3 1 2 3. So this is SP3. The previously I explained SP3. And this is how many? So 25% S character, 1 S orbital, and remaining 75% is 3 P orbital. What is the shape here? It is linear. This is linear. And bond angle 180 degree. See, 180 degree. This is trigonal, so bond angle 120 degree. Here 109.27 degree bond angle. SP3. SP3 has bond angle ಈ ತರ ಇರುತ್ತೆ ಆಯ್ತಾ ನೋಡಿ ಇದ್ರ ಈಗ ಒಂದು ಕಾರ್ಬನ್ ನಾನು ತಗೊಂಡ್ರೆ ಸೊ ದಿಸ್ ಇಸ್ SP3 ಹೈಬ್ರಿಡೈಸ್ ತಗೊಂಡ್ರೆ ಸೊ ಆಲ್ರೆಡಿ ಹೇಳಿದೆ ಕಾರ್ಬನ್ ಏನಿರುತ್ತೆ 4 ಮಿಕ್ಸ್ ಆಗಿ ಹೈಬ್ರಿಡೈಸ್ ಆಗಿರುತ್ತೆ SP3 ಹೈಬ್ರಿಡೈಸ್ ಆಗಿರುತ್ತೆ ಇದಕ್ಕೆ ಹೈಡ್ರೋಜನ್ ಇದಕ್ಕೆ ಹೈಡ್ರೋಜನ್ ಇದಕ್ಕೆ ಹೈಡ್ರೋಜನ್ ಇದಕ್ಕೆ hydrogen. These are at the sideway at position ಆಗಿರುತ್ತೆ. That's why it is sigma bond. So bond angle 109 degree ಇರುತ್ತೆ. Bond angle 0.27. ಆಯ್ತಾ these tetrahedral. These atoms are same. These atoms are tetrahedral. Same. So this ಹೇಗಿರುತ್ತೆ ನೆಕ್ಸ್ಟ್ ಹೈಡ್ರೋಜನ್ ನೆಕ್ಸ್ಟ್ ಇನ್ನೊಂದು ಹೈಡ್ರೋಜನ್ tetrahedral geometry SP3 hybridized. ಆಯ್ತಾ SP3 hybrid. So what is SP2? SP2 ಅಂದ್ರೆ SP2 is observed in SP 1 s orbital and remaining only remaining ಏನಾಗಿರುತ್ತೆ 2 SP2 ಆಗಿರುತ್ತೆ ಆಯ್ತಾ is px1 px2 in the excited state S ಇಂದ ಏನಾಗುತ್ತೆ ಎರಡು ಮಿಕ್ಸ್ ಆಗುತ್ತೆ S and P2. ಸೊ ಎರಡು ಮಿಕ್ಸ್ ಆಗಿ ಏನ್ ಬರುತ್ತೆ ನ್ಯೂ ಆರ್ಬಿಟಲ್ that is SP2 1s remaining to P. ಅದಕ್ಕೆ ಏನಂತ ಕರಿತೀವಿ SP2. ಸೊ ಒಂದು ಕಾರ್ಬನ್ ಅಲ್ಲಿ ನಾನು SP2 ಆರ್ಬಿಟಲ್ ನ ತಗೊಂಡು ಬರೆದ್ರೆ ರೈಟ್ ಕಾರ್ಬನ್ SP2 ಹೈಬ್ರಿಡೈಸ್ಡ್ ಆಯ್ತಾ ಸೊ ದಿಸ್ ಇಸ್ another carbon sigma bond is actually this one p orbital here. Actually how many p orbital here? 3 p orbital, 1 s orbital. 1 s orbital hybridized SP2 ಆಗಿದೆ. 1 p orbital remaining ಏನಿದೆ ಇದು empty ಇದೆ. ಆ empty ನೇ ಇದು empty p orbital ಆಯ್ತಾ empty p orbital. ಸೊ ಇನ್ನೂ ಮೂರು ಯಾವುದು ಇದು ಇಲೆಕ್ಟ್ರಾನ್ ಇಲ್ಲೊಂದು ಎಲೆಕ್ಟ್ರಾನ್ ಇರುತ್ತೆ ಸರಿ ಇಲ್ಲೊಂದು ಎಲೆಕ್ಟ್ರಾನ್ say this is electrons this one 1 2 3 1 2 3 and what is the remaining is orbital it remains same adine barkondirodu remains empty remaining 3 one more carbon remaining empty and remaining 3. So this hectate sigma bond but in the side way overlap empty ring. Empty is side over this hydrogen is also hydrogen. Aita idu kuda hydrogen agutta idu hydrogen one electron each electron from hydrogen hectate position idu nenu dorukutte carbon nodi ile ee hydrogen na I can write this one sigma bond 1 2 sigma bonds is side way overlap agirodana pi bond anta represent ಮಾಡ್ತೀವಿ hectate already one sigma bond ಇದೆ is sigma and remaining carbon next remaining 2 hydrogen. So that's why alkene as one pi bond, one sigma bond, and remaining these are all sigma bonds. This forms alkene. The bond angle already 120 degree ಇರ್ತದೆ. S character ಎಷ್ಟಿದೆ? ಇಲ್ಲಿ S character 35%, remaining is 65% P character. The pi bond is SP2 and again SP. So SP is P orbital and this is S orbital. ಇಲ್ಲೊಂದು ಎಲೆಕ್ಟ್ರಾನ್ ಇರುತ್ತೆ, ಇಲ್ಲೊಂದು ಎಲೆಕ್ಟ್ರಾನ್. ಇವೆರಡು ಮಿಕ್ಸ್ ಆಗಿ ಹೈಯರ್ ಎನರ್ಜಿ ನೆನಪಿರ್ತಾರೆ. ಇನ್ನೊಂದು ಒಮ್ಮೆ ಲೋಯರ್ ಎನರ್ಜಿಯಲ್ಲಿ ಎಷ್ಟು ಇರುತ್ತೆ, ಹೈಯರ್ ಎನರ್ಜಿ ಮಿಕ್ಸ್ ಆಗಿ ಇಲ್ಲಿಗೆ ದಿಸ್ SP ಒಂದು S ಒಂದು P, ರಿಮೈನಿಂಗ್ ಎಂಟಿ 2 ಮಿಕ್ಸ್ ಅಪ್ ಹೈಬ್ರಿಡೈಸ್ ಆಯ್ತು. ಕಾರ್ಬನ್ ಏನಾಯ್ತು, ಹೈಬ್ರಿಡೈಸ್ ಆಯ್ತು. ಆ ಕಾರ್ಬನ್ ಹೈಬ್ರಿಡೈಸ್ ಹೆಂಗ್ ಬರ್ಕೊಡ್ತೀನಿ, ಒಂದು ಆರ್ಬಿಟಲ್ ಇದನ್ನ ಆರ್ಬಿಟಲ್ ಈ ಬರ್ಕೊಡ್ತೀನಿ, ಇನ್ನೊಂದು ಆರ್ಬಿಟಲ್ ಈ ಬರ್ಕೊಡ್ತೀನಿ. ರಿಮೈನಿಂಗ್ 2 is remaining 2 empty ಆಗಿದೆ. ಸೊ ಒನ್ ಮೋರ್ ಕಾರ್ಬನ್, ಇನ್ನೊಂದು ಕಾರ್ಬನ್ ಅಟ್ಯಾಚ್ ಮಾಡ್ತೀವಿ ನಾವು. ಆ ಕಾರ್ಬನ್ ಸೇಮ್ ಆಯ್ತಾ. ರಿಮೈನಿಂಗ್ 2 p orbital and one more. This is sigma bond and this is hydrogen sigma bond and this is hydrogen sigma bond. Say sp li 2 electrons, one carbon, each carbon has 2 electrons, 1 2. ಆ ಒಂದು 2 ಇದು ಒಂದು ಕಾರ್ಬನ್, ನೆಕ್ಸ್ಟ್ ಕಾರ್ಬನ್ಗೆ ಸಿಗ್ಮಾ ಬಾಂಡ್ ಫಾರ್ಮ್ ಆಗಿದೆ, ಇನ್ನೊಂದು ಹೈಡ್ರೋಜನ್ಗೆ ಸಿಗ್ಮಾ. ರಿಮೈನಿಂಗ್ ಏನಾಗಿದೆ, ರಿಮೈನಿಂಗ್ ದಿಸ್ ಸೈಡ್ ವೇ ಫಾರ್ಮ್ಸ್ ಸೈಡ್ ವೇ ಓವರ್ಲ್ಯಾಪ್ಸ್. ಇದು ಇದಾಗಿದೆ, ಇದು ಓವರ್ಲ್ಯಾಪ್. This is one pi bond and remaining this one, another pi bond. So how many ಈ ಕಾರ್ಬನ್ ಗೆ ಒಂದು ಸಿಗ್ಮಾ ಬಾಂಡ್, 2 ಎಷ್ಟಿದೆ, 2 pi bond, 2 pi bond. So carbon, we take this carbon, one sigma bond, remaining 2 pi bond. What is hydrogen next? Only one hydrogen, and next remaining carbon also. This is SP hybridized. This is SP hybridized. Okay, now this is SP hybridized. So that's why it is linear, 180 degree structure, linear, 180 degree. That's why single bond is SP3 hybridized, double bond is SP2 hybridized, double bond is SP hybridized. This is the concept of SP, SP2 and SP3 hybridized. Okay, I'll stop this class here. So any doubt in this class?
So where we can get the recorded classes?